We were either lean manufacturing consultants in operations ourselves out in industry. We've done things like manage operations, manage quality departments, strategic sourcing, and so forth. So we all have that very functional background. But we also blend that with that deep subject matter expertise with software and technology knowledge. So where we really focus is at that intersection of technology and operations. And so that has us kind of uniquely positioned to work with Industry 4.0 and how to help our customers get value from that. So we've been doing this for a long time. We started implementing OEE systems back in the 2005 timeframe because we would go to a customer and they'd have lots of projects for us to work on. We'd walk the shop floor, we'd find a lot more projects to work on. And really it was trying to use data to identify, what are the biggest levers to pull for the business to affect the biggest change. And then once we started projects, we would spend 4, 6, 8 weeks collecting data to drive at the root cause analysis. And we figured there must be a better way, and that's how we kind of evolved into this process. So getting right into this, we believe that we have a proven path to success. We like to think big, then start small, move fast, and throughout it all drive value. And what we really want to do is begin with the end in mind, map out the vision, and then utilize that to set the vision, do the gap analysis, create the roadmap, and define that potential value. Then to get started quickly, we want to leverage the existing investments that are out there, fill in the gaps in the data collection, integrate across the different data sources, and throughout it all, really transform the culture and the processes. And this is really the part that gets left off a lot. I bought a Fitbit, but I'm still overweight. And the reason for that is that I haven't changed my behaviors. I still don't exercise enough. I still, eat too much and so forth. And because of that, I haven't lost any weight. And on average, people that buy Fitbits actually gain weight over time. And it's the same thing for companies in technology. Very often, they'll make an investment in whether it's the new Industry 4.0 technologies or whether it's other technologies. But if you don't adapt the culture of the business, if you don't change the processes, if you don't do something differently tomorrow than you do today, you've just spent a lot of money and you're not going to get anything from it. So let's start with that first piece, mapping out the vision. Industry 4.0 covers a lot of ground. There are a tremendous number of things that fall underneath that umbrella. Whether it's big data initiatives, collecting information from a wide variety of different sensors on the machines and so forth, blockchain, virtual reality, augmented reality, robots, etc. Machine learning, where you utilize a lot of that information and that detailed data that you're collecting and run that through algorithms to start to have the machine become more predictive about when failures are going to occur, when quality issues are going to occur, et cetera. And now directing people to take action upon that information. So a lot of these technologies are driving explosive growth. A lot of them are really changing how companies do business and approach the market, and offering up new opportunities for businesses to get into new markets or just improve how they do things in their existing one. So we like to think about the art of the possible. And if we look at the industrial Internet of Things, there's a lot of different capabilities that are there, all the way from manufacturing, engineering, and design, all the way through operations management and so forth. Just one quick example is we were working with a customer down in Houston that produced big, huge plastic sheets that went underneath the bottom of reservoirs to prevent leakage. And when we got there, they had people that were watching these 30-foot wide plastic sheets coming off of the extruders, visually looking for defects in that sheet. And if you can imagine standing there at the side of a plastic sheet that comes off in a continuous process for 8 hours a day, you're really good at the beginning of the day. And then as the day goes on, your attention starts to wander and you start to miss things and so forth. So there's a vision system that we put in place there that is able to pay rapt attention for 24 hours a day, 7 days a week, never miss a single defect. And by doing that and then being able to trace exactly where in the sheet that's happening and so forth, they were able to get significant quality improvements in their operation. And so that's just one quick example of the types of things that are possible using IIoT that haven't been possible in the past. From an augmented reality perspective, one of my favorite stories here is we talked to a company in New Zealand that produces products for farmers for milking cows and so forth. And if you think about the support process that they had as a small company that shipped their products worldwide, how do you, as a small New Zealand company, support product failures in the field in Montana? Or Africa or Asia, Europe, etc. And what they started doing is they started using augmented reality to ship a set of glasses with a camera out to their customers along with the product. And when they had a maintenance issue out in the field, instead of sending a service person out there and maintaining a huge trained service force out that could get to those remote places, by doing this they were able to provide remote expertise. And so the customer would put on the glasses, the remote support would be able to actually see what the customer was seeing with the machines and provide that remote expertise to help the customer fix the machine themselves and send out the service parts and so forth to make that happen. So tremendous things that are possible with a combination of IIoT, augmented reality, and other aspects of Industry 4.0. So with all these possibilities that are out there, how do you actually decide what it is that you're going to focus on first? Well, when we're working with our customers, what we try to do is let the business case make that decision. And that's easy to say, but how do you actually drive that from those top level issues as a company down to what project should I do first? Well, we start with that goals of the company, whether it's increasing market share, improving throughput, reducing the lead time from manufacturing out to the customer, or reducing inventory. And just to take that one as an example, if we identify too much inventory, finished goods inventory as the biggest problem here, we'll start to identify what are the proximate causes, what are the reasons why as much inventory is being carried today as it is. Presumably they're doing it for a reason. They're not just willy-nilly keeping millions of dollars worth of excess inventory. So what are the reasons why that much inventory is out there? And usually that comes down to they're unable to predict demand accurately. They have too much forecast error, and so they have to maintain inventory to cover the demand that they're not predicting. It comes down to supply variability. So I'm not able to trust that my own manufacturing plants are going to be able to provide the product that they said they would, so schedule adherence is poor, or they've got supply issues from their suppliers that are providing goods and so forth. And so those are kind of my proximate causes. But now I want to go down and do that root cause analysis to say why, what are the things that are preventing my forecast accuracy from being better? What are the things that are causing that amount of variability on the shop floor? And just as a couple of examples, for the forecast accuracy, it may be that I've already made an investment in good supply chain tools and forecasting tools and so forth, but it may be that I haven't trained people properly, or I don't have a good process in place. And so in that case, if I'm still using a simple moving average to do my statistical forecast, or I'm not incorporating all of the different causal factors and so forth, I need to re-engineer that forecasting process utilizing the tools that I have in place to do a better job. It may be that out on the shop floor where I have, a lot of variability that's causing this, and, poor schedule adherence and so forth, that, I have excessive downtime on my machines, I have poor control of my supply chain so that I'm not receiving the goods, and I'm shutting down my production as a result of quality problems for my suppliers or delivery problems for my suppliers, and that's causing me problems. And so it may be that for the downtime on my own shop floor, I reduce my downtime by putting predictive maintenance techniques in place and so forth, and so investing in that new technology and so forth. And so by doing this and getting down to those root causes, what I'm doing is I'm now able to tie an enabler to each one of those different root causes, or multiple enablers to those root causes. And those could be technology solutions, they could be process changes, they could be training issues with my personnel and so forth. But I'm going to identify what are the things that I need to do to address those root causes, and that defines my project portfolio for me. And so now I have a list of projects that I need to invest in, and I'm able to tie how much each of those is potentially worth, because I know what root causes they're addressing. I know how much those root causes are impacting my performance in those areas. And so now I'm able to create a very solid business case for addressing those root causes, putting those enablers in place, defining how I'm going to do business differently tomorrow than I do it today, and then what benefit I actually expect. So once I've got that vision mapped out, the first thing that I want to do is I want to start small. I want to drive some successes with this operation. If you have read Cotter and his 6 Steps to Change, you want to begin small. You want to be able to drive early successes. You want to communicate those successes to drive enthusiasm, to drive that sense of accomplishment, and then also to actually start to get some return on that investment to kind of pay for the rest of the projects going forward. And so I want to be able to move quickly by leveraging the investments that I've already made out on the shop floor. So I'll give a few examples of that. So every organization has some data that they're collecting already. And the key is how to utilize that data effectively to be able to drive these improvements. And so if you can leverage that data that you're already collecting to understand where performance is perhaps falling short today, be able to respond to issues a little bit faster by utilizing that data more effectively. Maybe you have some of the technology in place that you need, but you just need that process change to generate your forecast more accurately utilizing the tool that you already have. All of those are good things. There's also something called the Hawthorne effect. And a great example of this is at one of our customers, Penn Engineering, that we did a project for back in the mid-2000s. And with them, they had a level of performance on first shift, but as we started to analyze the data that was available to us, we saw that the second and third shift performance was up to about 30% lower than what they were getting on first shift. And by being able to identify that, what we were able to do is put some of these big screen displays out on the shop floor and actually show the metrics that we wanted to drive behavior on. And primarily for them, that was throughput and quality. And by putting this out there, it's kind of like a policeman on the side of the road. People behave differently when they know they're being watched. So you see the policeman on the side of the road, you slow down. It's the same thing with these boards. As long as the people on the shop floor know that management is actually looking at that and will engage them on the results of that, then they will behave differently. This is repeatedly proven impact. And so we just had the management team, the plant manager and so forth, spend time out there talking to the operators, pointing out the data on the boards that showed the performance from the first shift, where they're at, and not beating them up over it, but just asking them what else they need to be able to match that level of performance from the earlier shift. And it was almost magical. We almost got that entire 30% back just by having those visual displays on the shop floor. And so, these kinds of things can make a huge difference just from the data that you have today. Another example is with a customer up in Minnesota. With these guys, they had a very limited amount of information. Really, they just had some data from their ERP system that they were able to extract that showed them what was planned, what they actually did, and some information about what product family was being run, what line it was scheduled on, and so forth. But even utilizing about 6 pieces of data, what we're able to do is to identify where performance was good, where performance wasn't good, and be able to direct the improvement efforts to those places that needed help, as well as when you're thinking about making the investment of these Industry 4.0 capabilities and so forth, where do you want to make that investment first? What lines do you put this on first? Well, the lines that were struggling, and by doing this, we were able to identify which lines those were that needed that additional data collection first. Automating SQDCM, if you're not familiar with SQDCM, it is safety, quality, delivery, costs, manpower, or some customers call it a management operating system or a policy deployment framework. And what this really is, taking a simple example from a couple of customers in the automotive industry, the COO of these customers runs a weekly cadence call. And he has all of his direct reports on this call, and they were going through just a spreadsheet that had the KPIs in each one of those different categories of SQDCM, and running through whether they made the goal, whether they missed the goal, if they missed it, why they missed it, and what they were doing about it. And the spreadsheet, they had a new spreadsheet every week, and they weren't really able to look at the trends. They weren't able to look at these improvement efforts that were taking place and whether that actually made a difference in the level of performance and so forth. And so what we did was we took that information that they're already entering into the spreadsheet, and we just put it into a database instead. So we created a little web form and used that to put the information into the database. By doing that, we were able to now trend that information over time, look and see if it's getting better, if it's getting worse. We were able to track the reasons and see how those reasons repeated over time and whether the actions that they were taking were actually effective. And then the next step in that process was to link that down to the shop floor. So you want to take that high-level COO messaging around SQDCIM and now drive that to the plant level, drive that down to the value stream level, drive that down to the individual area within the plant, and keep that consistent metrics as you flow down that hierarchy. And by doing that, you put that whole management operating system in place and get everybody pulling the order in the same time and so forth, so you can get the maximum impact. So, what we like to talk about there is eventually getting to the point where you bottle the information at the source and, actually connect to the systems themselves on the shop floor and then roll that information up instead of people having to enter it in manually. And that kind of takes us to our next section here, which is filling in the gaps in the data collection. So you have your existing data collection that you have out there, but as you go through and identify, what are the potential enablers that you want to put in place, you'll identify gaps where you don't have the data that you need today, and you don't have systems out there that you might require. So how do you fill in those gaps? Well, first of all, data originates at every single step in the value chain, whether it's out at your suppliers, inbound logistics, receiving and inspection. This is a bakery example, so ingredient dispensing, mixing, and so forth on down the line, all the way to packaging, shipping out to the warehouse, and then out to the actual customers, and then point of sale information at the stores and so forth. And so there's data available at every single step along that entire value chain. And there are, purpose-built systems that you can put in place for each and every single one of those different steps. So you can either look to, implement these purpose-built systems for each and every single piece of that, or you can, look to put in a platform that takes the systems where you have them and wraps and extends around that, as well as then, filling in those gaps where it will now take the information from the process, whether that's the sensors or the PLCs, or CNC machine if you're in more industrial manufacturing, and now make that information available to all of these other processes in Industry 4.0 to drive those additional capabilities like the predictive and so forth. And so at Visual Decisions, we've looked at a lot of different solutions for doing this, and we strongly believe in the ThingWorx platform for this. It has that capability to wrap and extend the existing systems with its foundation with Kepware. It has connected to thousands and thousands of different devices out on the shop floor to be able to pull that information into the system and make it available for all of these different types of analysis that you can do now. And so we believe in the platform. Not only does it have those significant capabilities of what it can do, but it can also do it very quickly. And so it's possible to get ThingWorx connected and up and running actually in a matter of minutes sometimes. Certainly within a matter of hours, you can start to get that first data coming in, and you can actually commission a system in a matter of weeks. And it has a lot of built-in capabilities to identify what is happening out on the shop floor. So for instance, you can get information about your OEE, what is the current status, and send out alerts and things like that, as well as to see how that status changes over time. And that's all tremendous information. It tells you, gives you a very good picture of what is happening, can inform people, get that reaction started and so forth, as well as to now feed this information into higher levels of analysis. And one of the things that you want to do to expand beyond just looking at what is happening is to look at why it's happening. So in addition to just those performance metrics, what you really want to be able to get at is the diagnostic metrics. So it's the difference between what is happening and why is it happening. And just as a quick analogy for this, my son once brought home a report card that had a D in math. And first of all, knowing that he had a D in math, it was too late to do anything about it. It was the end of the semester. But what I really wanted to know was why he had the D in math. Did he just have one subject that he absolutely tanked? Was it that he wasn't doing the homework? Was it that he was just struggling with the subject in general and needed some assistance? Because what you do is different in each one of those cases. If he's just not doing the homework, maybe I give him a consistent kick in the butt to get him going. If it's that he had problems with one subject, maybe that's all done with, and it's not a problem going forward. But if he's struggling with it, maybe we get a tutor and so forth. Same thing out on the shop floor. Identifying what's happening is very important, but understanding why it's happening leads you to take different actions. As an example of this, going back to that bread company that we worked with for as an example, what we're able to do is collect that information from the shop floor and actually from several different systems, and now provide some guidance to them on how to analyze that. So the first dashboard that we put together was really looking at that what is happening, looking at the lost time that they had on their assets as well as the material waste that was being generated. And we could see how that trended over time. We could slice and dice that based on what line it was on. This was multi-plant, and so we could divide it up by plants and so forth and drill down into that information, look at performance day over day, week over week, month over month. And that gave them a really good picture of what was going on. But it still didn't drive down into that why. So the next thing that we did was we started to tag the information of every time the line stopped, why did it stop? Every time that we had waste, why was that waste generated? And by tagging that information, what we could then do is to start to drill into that data and start to analyze it in different ways. And so if we look up here where we have the area, the category, the cause, that's actually a drill down. So if I click on my equipment loss, then my biggest category underneath that is oven. And when I do that drill down, I see that I've got my equipment loss, my oven, and the shape of this curve changed dramatically. And what I saw was that I had a random amount of fluctuation each day, but there was a significant amount of loss at the top level each day. When I drill down to the oven, what I'm seeing is that normally it's pretty much all good. Then I have these big spikes that are happening periodically. And what that led me to understand is that we've got a preventive maintenance issue. So we don't have failures very often, but we have catastrophic errors that happen upon occasion. And the next level of information that we collected was really getting into the details of that problem. And so we started to understand that these spikes were happening because oven shelves were flipping due to broken pins. And as the pins would circulate through the oven, they would eventually fatigue, fail, shelf would collapse, and we'd have major problems with downtime, as well as with spoilage of the items that were under process at that point. And so we were able to get to the point where we identified the periodicity between these. We set up a preventive maintenance program to inspect the pins and replace the ones that were starting to wear, and basically completely eliminated the source of downtime for the customer. If we looked at a different failure mode, we would see a different pattern and understand that, for instance, there were a lot of jams that were happening. And for that, we were able to identify, some poka-yoke or arrow proofing that we could put in place to then, go out to the appropriate section, whether it was adjusting the railing, putting some silicone tape on the railing to have things flow through smoothly, or, other changes that needed to take place to eliminate those sources of downtime as well. But having the data and understanding not only what is happening, but why, allows you to, focus those efforts and really quickly go out and fix the problems. So that's the what and the why. The next step in that kind of maturity, if you will, is to go beyond that and start to do the predictive. So those first two steps, we call that descriptive analytics and then diagnostic analytics. The next step is the predictive analytics, and that's being able to take that data and start to now automate the process of doing that type of analysis that I did with the oven pins, and being able to now look at how frequently do I need to do different preventive maintenance. Can I predict based on signals coming from the assets themselves that I've got an impending failure? It might be that we're working with someone on a CNC lathe or something along those lines. You can do vibration analysis. You can do data on the load sensor for how much pressure there is. You can look at the amount of power being drawn, and all of those things become signals into am I about to break the tooling? Do I have a upcoming PM issue with the machine and so forth that needs to be addressed? And utilizing those predictive techniques to identify all of those and then take action. There's also prescriptive analytics, and what that does for me is to close that loop entirely. So a great example here is we were working with a firearms manufacturer, and they had an ammunition factory. And at the loaders, where they were actually putting the gunpowder into the rounds and then closing up the round for finished good, what they would do is they would build a certain amount of those, ship them off to the gallery to fire them, and look at the accuracy, the pressure, and velocity. And from those three factors, they would record those, they would put them in a spreadsheet, they would send that to engineering. Engineering would take a look at it and make changes to how much gunpowder should be loaded in there, because as you can imagine, gunpowder is very sensitive to humidity. And once you close that bullet, once you close the casing on that, the ambient conditions are sealed within that round forever. And so they would make recommendations on, adjusting the amount of gunpowder to get the proper level of performance. And then they'd send that off to the supervisor. The supervisor, when they got back to their office, would see that. They would then go out to the line, make the adjustment to the loader, make a few more units, and send those back off to the gallery for testing. And as you can imagine, this might take a while. Well, the plant was in Arkansas. And as you might imagine, conditions in Arkansas change fairly rapidly as far as humidity and ambient temperature and things like that go. And so by the time that they went through one of these cycles, it could be 8 hours. If it was near the end of a shift, it could be the next day. And we were able to collapse that down to 15 minutes by taking the information from the gallery, putting that into SQL Server, setting up triggers to do the analysis on that data, and automatically send that to the solution to do that analysis, and then go directly to the controller of the loader itself to make the proper adjustment in how many grains of gunpowder should be loaded. So we took a process that took hours and or days sometimes and pushed that down into about 15 minutes. And that's what the prescriptive analytics can do for you. So now we've filled in the gaps in the data collection. We're leveraging the data that we had already. The next step is to really integrate across different data sources. And so there's a tremendous amount of information that's available, not just from ThingWorx or whatever other system you have on the shop floor, but in many different data systems. And so how do you take that information from a lot of different systems and make use of all of that together? Well, the way that people do it today is they copy the information out of all of those different places into Excel, and they end up having all these Excel spreadsheets on their desktop. Kind of ends up looking like this. And so I don't know if you guys have that same situation, but the majority of customers that we talk to have this same problem where if you take a snapshot of a plant manager's desktop, he'll have 15 Excel spreadsheets open at the same time. So when we talk to customers, we very often talk about the F word. And no, it's not that one. It's a different one. It's fragmentation. And so fragmentation, talks to having all of these different systems in place that you have to go to get this information, and having this information kind of scattered amongst all of those different places, and having to go to all of them to really get to what you need. One quick example of this is that we worked with a customer that asked us to create a corporate quality dashboard for them. And we said, okay, not a problem. We can definitely do that. What are the systems that you have that have the information? And when we asked that question to IT, they said, oh, don't worry about it. All the information you need is in SAP. Well, it turned out that wasn't exactly true. So they did have information around scrap in SAP. They had some information about replacement part shipments and things like that. But that was kind of the extent of it. So we asked them about warranty data, and they had a homegrown system for warranty. And I knew that they not only did warranty repairs themselves, but they also had some outside providers that did warranty repairs for them. I asked them about that, and well, that was another homegrown database that didn't talk to the first one. Then they had another division of the business, and they had their own customer-facing warranty system and so forth. And so, that was more right there. But then when we talked about SPC information, statistical process control data, they had different systems in every single plant for that. Inbound inspection was typically being done in spreadsheets, but it was a different spreadsheet for every plant. End-of-line testing was being done, but that was typically in Access databases. Then you had laboratory systems in different plants. You had inline testing, where you had dedicated equipment that had their own system that they were putting information out to and so forth. And so in the end, we found 57 different systems just for quality data across 7 plants. And so when you think about the amount of data out there and so forth, when we talk about fragmentation, this is the kind of thing that we're talking about. How do you now, if you have a quality failure out in the field, how do you get information from 57 different systems to really analyze that. And that's just the beginning, because the quality data itself isn't the complete picture about quality. You have to place that within the context of, well, if your machine is going up and down all the time, that's probably going to lead to some quality issues. So your maintenance information is important. Your information from your laboratory information management system is going to be important. Your product lifecycle data and so forth, your production data and so forth. And so all of these things become very important when analyzing those issues. And how do I pull the information together to create that comprehensive picture? It's a huge challenge for a lot of customers, and it also leads to a real discussion between the shop floor systems that are out there that really look at things like the sensors and the SCADA systems and so forth versus your IT systems with ERP and your data warehouses and so forth. They're really on the other side of the wall. So you've got your IT department that's managing one side of that. You've got your people in the shop floor that are managing the other side of that, your controls engineers and so forth. And up until today, they haven't really talked to each other. And that's part of the beauty of a system like a ThingWorx, is that it can really bridge that gap. And Industry 4.0 requires information from all of that to be able to set that proper context and get all of the information that's required in order to do predictive and so forth. And so just as an example, as we talked to a customer one time, and we had the IT department that was there at the beginning of this ThingWorx and Industry 4.0 session that we're doing to kick things off at the plant. And we had the IT person actually draw what the IT infrastructure was. And so he drew this picture on a flip chart, and it had their Oracle ERP system and their data warehouse. They were getting point of sale information from their customers. They had this one division that they purchased that had a different ERP. They had Agile for PLM and so forth. And then they had OBIEE over here, and they had Tableau for data analysis. Then they had Hyperion for financial analysis and so forth. And basically he went and sat down after he had drawn that all up. And I asked him, well, what about the plants? And he came back up and he drew this little circle for plants and had the arrow here going to their big data store, because for him that was the information about the plants. And so this divide has existed and it has to be overcome. So just as an example, I won't go through all of the information on this slide, but what you really have to be able to do is to leverage that existing data, take that first step. You have to fill in the data collection gaps, and you have to be able to integrate to other data sources. And all along the way, you have to keep that focus on, now as I put these capabilities in place, how do I actually now take advantage of those? How do I do that work to transform the process, to train my people and so forth, because it really is a new world of work out there. And so one of the ways that this can be done is to give the right information to people for whatever it is that they need to do. And so we look at these mashups and that we can do with ThingWorx and other systems. And what this does is it pulls information from a variety of different places, but condenses it for the role, for the needs of the person at that time, at that place. And so just as an example for an operator, but you could have a different mashup for engineering and quality and so forth. We're able to provide that information to the operator with information from the manufacturing systems, whether it's ERP or MES, about what product are they making, what's coming next, how big is the work order, how many pieces do they need to produce, the work instructions that they need to manage, being able to enter the quality information, the data capture and so forth, looking at some of the streaming data coming from the industrial tooling, the torque, where they're at with that, and being able to provide them that feedback and so forth. And that's really the state of the art today. Now, as we look into the future and some of the augmented reality capabilities that are there, some of the machine learning that can provide higher level analysis and so forth on what needs to be done and so forth. The future is looking even brighter than what we have today, because this will be more context sensitive, it will be more intelligent, but it is coming. And some companies are actually doing pilots with this type of thing today, and ThingWorks with the Vuforia solution certainly supports all of that. But you can make a lot of improvements just by providing that context information on a single screen like we have here. So that final step is really transforming the culture and the process. And as I said at the beginning, somebody has to do that hard work of not only putting the solution in place, but now how do you utilize that solution to drive the improvements? Again, I'll use the analogy of the Fitbit. I can't just buy the Fitbit and magically lose weight. I actually have to do that hard work of getting more exercise and controlling my diet and having those disciplines and so forth. And if I don't do that, I'm not going to lose the weight. And it is the same thing out in business. Just investing in these technologies, you can invest in all the predictive maintenance technologies that you want, but if somebody doesn't go out there and actually change the PM scheme as a result of that, then you haven't really done anything other than spend money. So we all came from lean background at Visual Decisions, and so I feel pretty good in saying that manufacturing has really embraced technology and automation, but an awful lot of people in continuous improvement have not. They still have very, often old school mentality of, doing things manually. And so you get, the manual boards, you get manual tick sheets, you get, all kinds of things that are being done the old-fashioned way. And I understand that at first you want to be able to get the understanding and drive, a deeper appreciation for, what's being done and so forth. But even Toyota themselves got to the point where they said that, this is good at first, but once the people have that understanding, if you don't automate the process eventually, then you're just wasting human potential, the eighth waste. And so, what you want to be able to do is, improve that engagement, improve that transparency, go beyond what can be written on a whiteboard to, have those additional capabilities that are facilitated by the additional sensors, the additional data, the additional analysis that can be done with Industry 4.0 tools. And you also want to really focus on incorporating those new capabilities into standard work. When I'm talking about standard work, I'm not just talking about standard work for operators on the shop floor. I'm talking about standard work for engineers, for maintenance, for quality, for leaders, for management. And how does everybody incorporate these new capabilities into what they do on a daily basis? So it's not just your shift handoff meetings where you want to be looking at this data, but you want to say, how do my engineers on a daily basis utilize the capabilities that I have from this machine learning application that I've put in place that I've invested in? How do I get my people to both guide and inform that machine learning algorithm, but then also utilize the output from that to change how they behave and what they do on a daily basis? And so we really focus on that concept of standard work, not just for the shop floor, but for leaders as well. The metrics that you track should definitely align to the process itself. And so not just your manufacturing process, but your improvement process as well. And so just as an example of that, looking at root cause analysis, something I've focused on a few times, but root cause analysis is often done today by the continuous improvement team by going out there, clipboard, stopwatch, collecting data manually and so forth. And that's great, but it also leads to a lot of things where you latch onto an early hypothesis and now everything becomes collecting data to support that hypothesis. If you can collect data 24 hours a day to begin with, now you're in a position where you have the data already. How do you put the right root cause analysis process in place to take advantage of all of that information that you have and making that available, giving people the right training to be able to interpret that information, as well as to now take the action upon that. And finally, coming back to that analogy again, it's not simply putting the technology in place. The technology is wonderful. The technology provides tremendous new capabilities for your business, but just having that alone won't drive the improvement. To really drive that, actions have to be taken. Again, the business has to do something differently tomorrow than they do today to get the value. You have to look at the culture and how the culture becomes, more data-based, data-informed, and creating that culture of improvement based on these capabilities. And, doing the better root cause analysis, implementing permanent solutions to the problems that are out there to really address those root causes for those big problems that we had in the business case, and letting that business case really define what are the actions that need to be taken, what are the projects that have to be put in place, and what are the improvements that need to be made. So with that, we do run workshops for that visioning session and so forth. But at this point, I'll open it up to questions, and my partner Dan to throw in his comments as well.
At this point, Tim, I don't see any questions.
Okay. Dan, if you're talking, you're on mute. Do you have any comments you'd like to add?
Sustained throughout the process. Obviously, there's a starting point and kind of a continual, but how do you keep the executives involved in the process?
I think you were on mute for the first part of the question, but I understood where you're going correctly. The executives are obviously going to write the check at the beginning of this process to get started, but in terms of keeping them involved and so forth, what you have to do is engage them on the things that they care about. So when we're doing that visioning piece up front, we are talking about those big problems as we're defining what the business case for this is. And when you're addressing the lead time to the market, how much time I have in that manufacturing process, my throughput, my market share, the design process, how long it takes to introduce new products to the marketplace and so forth. Those are questions that they care about. And so if you've done your job correctly up front, and they understand the linkage between those problems down to the impediments and the root causes that are driving those, over to the projects that you're going to put in place to enable the root causes to be addressed and so forth, you should have their attention up front. And as long as you are facilitating the good communication with them and you're driving those early successes so that they can see the progress is being made, you should be able to maintain their involvement throughout.
Okay.
All right. I think that's it. So I want to thank everybody for their time, and I will let you all go now. Thank you.